Okay, we are moving on to our linear unit. And the first thing before we can start applying linear equations is understanding what slope is. So your learning target today, you can identify slope given a line or a table. We're not doing points today, points will be tomorrow. So you can identify slope given a line or a table. Slope represents steepness. It means how fast is your height changing. When you think about going skiing, you're hitting the slopes. Well, slopes represent, you can be a really steep hill, or you could be on a little bunny hill. It's how quickly your height changes. That's what slope represents. Your change in height and how fast you're changing. So the steeper the slope means that the more your height is changing in a shorter amount of time. The more gradual a slope means it takes longer to change your elevation. Positive slope means you go up. So draw some examples of a line. A line has arrows, a line going up. Positive slope. Try to draw a gradual positive slope. Oops. Make sure it's a line. Mine kind of doesn't look like a line. But positive slope means you're going up when you go left to right. Do a really steep one.
Okay, I can.
Not vertical though, not completely vertical. That's a different slope. All right, so that's positive slope going up. So negative slope, what do you think that means? If positive is going up, negative is
Down.
Yep, going down. So that means that's like skiing, like you're going down when you go left to right. Make a steep one. Make a super gradual one. Whatever, just make any kind. As long as you know that negative slopes go down, positive slopes go up. Zero slope, you don't go up or down. You're not changing your elevation. Remember, slope is steepness. Zero slope means there's no steepness. No steepness is a horizontal line. Make it a true line, mine is curved. But it's a horizontal line. No steepness. No change in your elevation. So make some examples. Zero slope, zero slope, zero slope. You could go all along that y-axis. Zero slope is just any horizontal line. And undefined means there's no way that you could climb it. Remember, it represents steepness. So you can climb a mountain, you can ski down a hill, a mountain. Undefined means nope, you definitely cannot, and that's those vertical lines. So that's like this. You cannot ski or climb that unless without supernatural powers. Okay, you cannot ski or climb this. So some examples.
Whoa,
Well,
it's so difficult to draw.
my lines, yeah, don't judge my lines. I know that they're not beautiful.
No.
But it's anything that is a vertical line. So you need to be able to identify your learning target. If I gave you a line that looked like this horizontal or this vertical, and I said, what's the slope? You have to say, hey, you're not going up or down. This is a zero slope. Hey, there's no way I can climb that thing. That's undefined. Nope, no way. You can climb this still. You're just not working that hard. It's just zero. It's like walking along the classroom. All right, so 4 types of slopes. You're either positive, negative, zero, or undefined. That's the 4 types of slopes. Next. Okay. Now remember we said that slope represents steepness. It's how quickly your height is changing. Height is tall. Tall means, when you think about about steepness, and you think, how fast is my height changing? That means you want to know how much is your y changing over how fast does your x change. That's what that means. Y change to x change when you think about slope. And if you're a steep slope, your y changes really fast, and your x always change constant. You're always going by 1. It's how much does that y change. So y is the dominant factor of slope, because that's representing height and steepness. So slope, what we call it to identify it, is rise over run. Rise is y change over x change. Rise over run. Slope. Rise over run. Remember doing this in 7th grade? Slightly towards the end of the year we did it. MCA time approximately we got to it. So, how your y changes over how your x changes. And you always go left, left to right. That's always how you identify the change. Okay, left to right. All right. And you always start with a left point. So look at here, here's a left point, and I go to my next perfect point. You always do y first. Y is the most important thing with the slope. How your y changes over how your x. So I want to know slope is rise over run, which is your y over x. How your y, it's called delta. Do you remember, maybe, didn't I do this? Delta y means like how did your y change over delta x. You want to see how pretty that looks? Triangle y, that means delta y, how your y changes. Over triangle x, delta x, how your x changes. Okay, so when I look right here, how did my y change to get to my next point? Well, I went up 1, 2, and I went over, here's my run. 1, 2, 3, 4. I went up 2, over 4. Do it again. Up 2, 1, 2, over 4. 1, 2, 3, and there's my perfect point. Which is, you have to simplify it, 1/2. So look at it. Watch slope. Slope is constant because these are linear equations, which means they're always increasing at the same rate. So my slope is 1 over 2. Watch if I start here. Up 1 over 1, 2 point. Up 1 over 1, 2. Up 1. It's hard to see. Up 1 over 1, 2. Up 1 over 1, 2. Is the line going to cross that point? Sure is going to cross that point. Slope is constant. As long as you know a slope, you can graph an equation without a table. And what we did in Unit 4 is used a table. Okay, the next one, again, you start at the left point. So my left point is this one right here. And I need to get to my next point. So you do y first. So how did my y change over how did my x change? My y changed by going down 1, 2, down 2, over 1, 2, 3, 4, and 5. Down 2, over 5. Very critical that you start at that left point. Because if you don't start at the left point, you're going to say it's positive. But this line goes down, so you should know it's a negative slope. Hey, look at these. You want to know what? They don't have our perfect points. So you need to find perfect points. You might choose different perfect points than me, but we'll still get the same slope, because slope is always the same. So I'm going to choose a perfect point on the left. So here we go, perfect point. And then I'm going to find another perfect point. I'm going to choose this one. That's not my next perfect point, but I'm just going to show you it doesn't matter what your perfect points are. So slope is rise over run, which means you do y and then x. Change in y over change in x. So start at your left, If you forget, do you see what I'm doing when I do that? That's so elementary, but I used to have to do it all the time because my left hand makes the L. So I start at my left point and I say, how did my Y change? I went down 2, and then over 1, 2, 3, and 4. Down 2 over 4. Or down 1 over 2. Simplify. And let's just double check my slope. So I should be able to pick any point and go down 1 over 2 and get to the line. Down 1 over 1, 2, yep. Down 1 over 1, 2, yep. Down 1 over 2, yep, always works. So I definitely calculated my slope right. The next one, again, you pick a left point and go to the right point. So here's a perfect point. And another perfect point is right here, it looks like. You start at the left one. Again, if some of you are wondering what I'm doing here, my goal is to find perfect points. And a perfect point are where 2 lines intersect. That's a perfect point. A perfect point is not, this is not a perfect point right here, because it's only on one grid line. Okay? So again, perfect point was right here and right here. Change in Y over change in X. How much did I go up? 2. How much did I go over? 1. Up 2, 1, 2 over 1. Up 2 over 1. Up 2 over 1. Up 2 over 1. It will always be that way. All right, we're moving on to the last part of our learning target, which we have met before in Unit 4 when we identified linear and nonlinear. And you're going to identify slope given the table. Finding slope given a table. Slope is rise over run. Rise is your Y, so we say change in Y. Run is your X, change in X. So to find slope given a table, you do how your Y changes over how your X changes. So given this first table here, I want to be able to identify the slope, change in Y over change in X. How does Y change? Plus 4, plus 4. So I'm adding 4 over, how did my X change? Plus 2, plus 2. 4 over 2, which is 2 over 1. Okay, the next table, change in Y over, Y has to be first. It has to, you have no choice. Y has to be first. That's the definition of slope. Y is the one that's on top. So, what did I do here? I subtracted 2, didn't I? From -6 to -8, I went 2 more negative. Subtracted 2, so change in Y over change in X, minus 2 over, what's this? Minus 3?
Yep.
Minus 3. Hey, look. What happens to those 2 negatives? And it equals a positive. So it's just a positive 2 over 3 is my slope from this table.